oppose of flow of current.
Yeah.
Resistance is the oppose of flow of current. Like resistivity basically is constant for certain material. Okay, if you
Okay.
take two different material, then resistivity will be different. So this can be derived from this formula. Resistance is given by rho L by A. Now from this formula we can calculate the resistivity. So resistivity will become R A by L. R A by L.
Yeah.
This is the resistivity. Okay. So now if anyone want to know the unit of resistivity, then also we can calculate. So resistivity, this is resistance, this is area, this is length. Okay, unit. Now I am talking about unit. What will be the unit? So here is resistance. Unit of resistance is ohm.
Yeah.
Unit of area is meter square. Okay. Unit of
Okay.
area is meter square. Divided by unit of length is meter. So meter and meter square will be cancelled out. So unit of resistivity will be ohm meter.
Yes.
Unit of resistivity will be ohm meter. Okay. And what you have told me? Conductivity. You told me na conductivity. Or
Yeah.
that is not inductivity. That is conductivity. So basically, conductivity is the reciprocal of resistivity. Conductivity. Sigma. Sigma is
Yeah.
known as the conductivity. And there
Yes.
is one more sigma we have studied, surface charge density in electrostatics. Sigma is also, that sigma is different, this sigma is different. So basically conductivity is 1 upon resistivity. So now resistivity is this, na? Resistivity is this. So do the reciprocal of this, you will get the L by RA. And what will be the unit? If I am talking about the unit of conductivity, then do the inverse of this unit. So unit will be ohm inverse meter inverse. You can write it like this: ohm meter inverse, the conductivity. Okay.
Okay.
Resistance you should know, resistance, and from the resistance you can derive the resistivity. Okay. So
Okay.
basically, resistivity is a property of the material. Resistivity is the property of material. Have you heard about the relaxation time?
I think so.
Relax,
Yeah.
relaxation time. Okay, no problem. So got it, na resistivity?
Yes, sir.
This is very simple topic. Okay, no problem. Mm, so now we were discussing the pure resistive circuit, pure inductive circuit, and pure capacitive circuit. So this is just the revision because
Okay.
I will use all these expression uh, for the series LCR circuit. So in pure resistive circuit, see the equation of the voltage and the equation of the current. V is equal to V naught sine omega t. I is equal to I naught sine omega t. And what is this omega t? I have told you this omega t is known as the phase. This
Yes.
omega t is the phase. The angle with sine is phase. So see, here is omega t, here is omega t. So phase difference between the voltage and the current in pure resistive circuit is same. So
Okay.
here it is shown that voltage and the current are in same direction. Okay, and peak value of the current is equal to peak value of the voltage divided by the resistance of the circuit. Now, talking about the pure inductive circuit. Actually, we have already discussed all these things in detail in the last class. So we are just revising. So see the equation of the voltage and the current. Equation of the voltage is V is equal to V naught sine omega t. I is equal to I naught sine omega t minus pi by 2. So this is the phase of voltage, this is the phase of current.
Correct.
So
Yes.
now here we can say the current is lagging behind, the current is lagging behind then voltage by 90 degree. So you can see
Yes.
this diagram. Here current is in this direction and
Yes.
voltage is in this direction and angle is 90 degree. So current is lagging behind from the voltage by 90 degree.
Mind.
There is one another term, axle, inductive reactance. I have told you inductive reactance is like resistance, like the unit of resistance is ohm,
Yes.
unit of inductive reactance is also ohm. So basically you can say this is just like a resistance in inductive circuit. In the resistive circuit we have the resistance, very famous resistance.
Yes.
As in case of the pure inductive circuit we have inductive reactance, so this is represented by xl. xl is equal to the omega l. What is omega? Omega is equal to 2 pi into frequency. Okay, if in this circuit if you want the peak value of the current, then you will write I naught is equal to v naught by xl. I naught is the peak value of the current, v naught is the peak value of the voltage, and xl is the xl.
Yeah.
Pure capacitive circuit, these two equations you have to remember. Okay,
Okay, sir.
and these two equations means equation of the current and the voltage you should know, or you should know that in inductive circuit whether the current is lagging behind or the inductor or the voltage is lagging behind. But in case of this pure capacitive circuit, what is the meaning of the pure capacitive circuit? Only capacitor is connected with an alternating voltage source. See the equation of the voltage and the current equation, and see the phase. Here phase is omega t of voltage and phase of current is omega t plus pi by 2. So from this equation you can say that the current is leading or lagging. Current is
Leading.
leading
Leading. Yeah.
because the phase of the current is greater than the phase of the voltage.
Yes.
I is equal to I naught sine omega t plus pi by 2. This is the
Yes.
phase of the current. So current is leading then the voltage by pi by 2. So see here, this current is leading the voltage by pi by 2. So
Bye
this
bye.
is your voltage and current is leading the voltage by pi by 2. This is the current. So for capacitive circuit, if you want to find the peak value of the current, then you will write peak value of the voltage divided by Xc. What is Xc? Capacitive reactance. Xc
Yes.
is the capacitive reactance is given by 1 upon omega c. And what is C? C is the capacitance. C is the capacitance. So basically, now we will connect the inductor, capacitor, and the resistor in series, and we will see what will be the equation of the voltage, what will be the equation of the current. Okay,
Okay.
and what type of phasor diagram we will have in this. So basically series LCR circuit. So I think today's lecture will be on this topic only. Okay, so
Okay.
series LCR circuit, series, we know series like
Yes.
series combination of resistance,
Yes.
like series combination of capacitors. Here series combination of inductor, capacitor, and resistor. And what is this? This is an alternating voltage source. This is
Yes.
an alternating voltage source. I have written VT, so the function of T means the voltage is changing with time. Voltage is changing with time.
Mm.
Okay. Okay. So at any time, suppose at any time the current in this circuit is I is equal to I naught sine omega t. Suppose at any time in this circuit the current is I is equal to I naught sine omega t. Current will be this because
Yeah.
here is alternating voltage source.
Yes.
That is why the equation of the current is I is equal to I naught sine omega t. I have just assumed that at any instant of time the direction of the current is this and the equation of the current is I is equal to I naught sine omega t. Okay. Here is a voltage source,
Yes.
alternating voltage source. So Across the inductor, there will be the voltage. Across the capacitor also there will be the voltage. Across the resistor there will be the voltage. Voltage across inductor, voltage across capacitor, voltage across resistor. Okay.
Okay.
Okay. So if I want to write voltage across resistance at any time t, you can say that here is an alternating voltage source. So this here the voltage across the resistance will change with time. Change with time, na? Not
Yeah.
constant. This voltage will not constant because
Yeah.
because of this alternating voltage source.
Yes.
This voltage is also changes with time. So here also the voltage will change with time. So suppose the equation of the voltage, okay, across the
Yeah.
resistance is this. Voltage across the resistance at any time t is equal to the peak voltage across the resistance sine omega t. Okay, and here what I have used, we know that this is the equation of the current and
Yes.
this is the equation of the voltage for resistance. Here is phase omega t of current, here is phase omega t of voltage. We know that in case of resistance, in case of resistive circuit, the phase difference of the current and the voltage is same na?
Yeah.
Okay, so this
Yes.
thing clear. If you want to calculate the peak value of voltage across resistance, then it will be I naught into R. It will be I naught, V is equal to IR. Okay, I
Yeah.
naught into R. That is why I have written these equations for the revision. Okay. Okay. Now for the inductor, VL is the voltage across the inductor at any instant of time.
Yes.
VL T representing the voltage across the inductor at any instant of time. So equation of the current is this: I is equal to I naught sine omega t. What is the phase of the current? One thing, remember one thing. Remember, this is the series circuit, na? So
Yeah.
current in inductor, current in capacitor, and current in resistor will be same because this is a series combination.
Okay.
In series combination, we know that the current remains same. In parallel
Yeah.
combination, voltage remains same. So
Yeah.
here the current is same. So what is the phase of the, now see the inductor. We are writing the voltage equation of inductor. See this. What is the phase of the current? Omega t.
Omega t. Yeah.
And in case of inductor, in case of inductor, I have told you voltage leads the current by pi by 2.
Yeah. Plus pi
So
by.
phase of the voltage will be 90° more than the current.
Yes. Yeah.
So that is why this is voltage across the inductor is equal to V naught L sine omega t plus pi by 2. Okay.
Okay.
Why I have written here omega t plus pi by 2? Because in case of inductor, the voltage leads the current by pi by 2.
Yes. So plus pi by 2, right?
Yeah, that is why we have written plus pi by 2.
Okay.
Okay, so now here for the capacitor, this is very easy. Voltage equation will be V is equal to V naught C sine omega t minus pi by 2, because in case of the capacitor, voltage lags the current by pi by 2. And all these things you already know. I have told you all these things. Peak value of the voltage across capacitor is equal to the peak value of the current into Xc. Xc is the capacitive reactance. Xc is
Yes.
the capacitive reactance.
Yes. Yes.
Okay. Now we will draw these equation we want for the
Yes.
phasor diagram. Basically,
Yeah.
we should know the equation of the voltage and the equation of the current we should know. Okay, now one by one we will discuss. One by one we will discuss. I want to draw the phasor diagram because this is a AC circuit, not the DC circuit. This is the
Yeah.
AC circuit. So it is
Yes.
better to draw the phasor diagram to analyze the circuit easily. To analyze the circuit
Easy.
easily. Okay, so now see, I will draw the phasor diagram. This phasor diagram is very, very important. Very, very important. Okay, I have drawn this.
Yes.
Now, just a minute. Actually, this cursor sometimes does not work. So, okay, so, hmm. Okay, so now this is the voltage across the resistance. This is the voltage across the resistance. Okay.
Yeah.
If I say that, if I say that current is in this direction, I. This is current, I.
Okay.
So what you will say the direction of the voltage across the resistor? In case of the resistance circuit, voltage and the current are in same phase. Voltage and current are in same phase, or you can say in same direction.
Yeah.
Same phase. So this V voltage across the resistance will be same in the direction of the current. Will be in
Yes.
the direction of the current. So
Yes.
here will be our peak voltage across the resistance. So peak voltage why I am writing this. This is the suppose if this is the direction of the current, then direction of the voltage across the resistance will be same. Or you can say current and the voltage are in same phase. For case
Yeah.
of resistance, for case of resistance. Now for case of inductor, for case of inductor, voltage leads the current by pi by 2. So we will
Yes.
draw like this.
So
Peak value of the voltage across the inductor. See, this angle is 90 degree.
90.
See, now you can see here, this is the current and this is the voltage.
Yes.
So this is the voltage across inductor, and voltage across inductor leads the current by
Pi by 2.
pi by 2. Now tell me, what will be the peak value of the voltage, or how to draw the peak value of the voltage for capacitor.
Capacitor.
See the equation of the current and
It
equation of the
lags.
voltage.
It lags by pi by 2.
Lect by 90 degree.
Yeah.
Lex by
Lags by
90 degree.
9.
So we will
Yeah.
draw like this.
Yeah.
We will
So
draw
draw
like
it.
this.
Yeah.
This will be peak value of the voltage across the capacitor.
Capacitor. Yeah.
Simple.
Yes.
Now game is over. This diagram is important. So basically this is a phasor diagram. What type of diagram is this? Phasor diagram. Phasor diagram. Now we can draw this diagram in another way also. This is the current direction. This is the current I. So in terms of the impedance or in terms of the resistance, if I want to draw this diagram, so in this direction will be the resistance, here will be your XL, here will be your XC. Okay, because this is
Yeah.
your
Okay.
voltage na, this is
Yeah.
your voltage na. So just a minute, how I have written this thing here, because you know that V naught L is equal to I naught into XL. So you
Yes.
can say that I naught will be the constant value. So V naught is
Yeah.
directly proportional to XL. So instead of V naught, we can draw the graph, we can draw the phasor diagram XL. Same is the case for XC. Same
Yeah.
is the case for the resistance. So this will be the another diagram. This will be the another diagram.
Okay.
Okay, now one by one. You can just imagine this as two vectors acting in opposite direction. Two vectors acting in opposite
Opposite.
direction.
Yeah.
So one by one we will take the cases. One by one we will take the cases. So first case number one. Case number one, when voltage peak value of the voltage across the inductor is greater than the peak value of the voltage across the capacitor, or you can say XL greater than XC. We can say XL greater than XC because
Yeah.
see here V naught L can be written as I naught into XL
Yes.
is greater than I naught into XC. So I naught will be cancelled out. So you can say XL can be greater than
XC.
XC. Okay. So okay, now in this diagram, what they are saying, this V naught is greater than V naught L is greater than V naught C. So we can
Yeah.
modify this diagram. We can modify this diagram. See, this is looking like two vectors acting in opposite direction. Two
Yes.
vectors acting in opposite direction. So we will modify this. Okay, so I can write this as V naught L minus V naught into C. Okay, so I have just subtracted uh, this value from this value for the resultant voltage. Okay, what we do if we have two vectors, suppose A vector and suppose if we have B vector,
So
two
XL
vectors are
minus
acting.
XC.
Yeah, no, this is basically right now we have not written XL minus XC. Basically, this
Okay.
is the voltage I have written, voltage part. So just
Okay.
just see here, if what will happen, suppose two vectors are acting, first one vector is acting in this direction, another vector acting in this direction. If I am saying A is greater than B, then A is greater than B, then net vector addition or the resultant of vector you will write like A minus B na. So
Yeah.
this is the case here.
Okay.
Okay, so this will be the phasor diagram when okay. Okay, now see, there is one more case in vectors. It is looking like that one vector is in this direction.
Yeah.
This becomes the whole vector. One vector is in this direction, are acting at 90-degree angle. So there will be one resultant also. There will be one resultant also of these vectors.
Yes.
Resultant will be like this. This will be suppose the resultant voltage V naught. V naught will be the resultant voltage. Now, how we will calculate the V naught? We know if two vectors are acting at 90-degree, this is A vector, this is your B vector,
Yeah. Yeah.
90-degree. So, if you want to find the resultant R, then you write A square plus B square. Okay, A square plus B square. So, here if you want to find this V naught, na, then
Yes.
you have to write this like this. This will be V naught, and you can write this as V naught under root of this square plus this square means V naught of L, or you can write like this. First you should write this square, V naught into R square plus V naught L square minus V naught of C square. So this will be the peak voltage of the circuit. This will be the peak voltage of the circuit.
Okay, sir.
Peak voltage of the circuit. Now we can further solve it. This is V naught.
Yeah.
This is under root, and V naught R can be written as I naught into R and square, plus this thing can be written as I naught into XL square
Yeah.
minus this can be written as I naught into
XC.
XC square. Okay, so this is your V naught, and
Sir,
yeah.
why are we taking I0? I know.
Oh, I0. I0, I have told you what is I0. I0 is basically the peak current.
Okay, okay, sir.
Why I am taking the peak current? Because this peak current is the constant value. Peak
Okay.
value is constant value. If we will take any other value, then we cannot solve it. Why? Because
Yeah.
that value will always change with time. Will
Yeah,
always
okay.
change with time. This see the difference between the values. This is the value, instantaneous value, and this is the peak value. So we
Yeah.
solve the circuit by taking the peak values,
Okay, sir.
not these value. Why? Because these value changes with time.
Change with time, yeah.
Yeah. Okay. Now from here you can write this will become I naught square R square, plus from here you can take I naught common. So this will become I naught square, and finally it will become
XL minus
XL
XC,
minus XC
XC
square.
square. Yeah.
This is V naught is equal to, you can take I naught common. So
Yeah.
I naught will be out, and this will become R
Yes.
square plus XL minus XC square. Okay. From here we will get a new thing. We know that voltage is equal to current into resistance
Yeah.
in case of the resistive circuit. In case of the resistive circuit. But here it is written that in the series LCR circuit, voltage is equal to current into something. We don't know what is this something. I will tell you what is this something. Basically, this is like the resistance. I am not saying this is a resistance. I am saying this is like the resistance of the series LCR circuit. This is known as the impedance. This is known as the impedance. And impedance is represented by Z. So this will be impedance of the circuit, R square plus XL minus XC square. So impedance of the series LCR circuit is this. Now what is this Z? Z is the impedance. Z is the impedance.
Impedance of LCR circuit.
Yeah, impedance of this circuit, LCR circuit.
Okay. Okay, sir.
Because this is a LCR circuit. Okay.
Yeah.
So this is the impedance.
Okay.
This chapter is easy, but at the same time, previous things will be used. That is why it may look complex, but this is easy.
Yeah.
Okay, so this is your impedance. So if you want the peak value of the voltage, then you can write V naught is equal to I naught into Z. I naught into Z. This equation you can use. Okay, now if we have calculated the impedance of the circuit. Now we want to calculate the phase. We want to calculate the phase of this circuit. Okay, we want to calculate the phase of the circuit. Okay,
Yeah.
so what I am doing here, we know the current in the circuit is equal to I is equal to I naught sine omega t. I is equal to I naught sine omega t.
Yes.
Now I will use this diagram. We can use this diagram also, no problem.
Okay.
So this diagram will be reduced to this diagram, because here your XL is greater than XC. Oh, sorry, XL is greater than XC. So so this diagram will be like XL minus XC. Okay, and this
Okay.
is the resistance. This length is representing the resistance. This is the XL minus XC. Resultant of XL minus XC is Z. Resultant of XL minus XC is Z. This Z
Yeah.
is making an angle of phi. This Z is making an angle of phi.
Right.
Okay. So from here also we can calculate the value of the Z, but we have already calculated Z. If you want, then I can calculate. Otherwise, what I want is 10 phi from here. I want this phi. I want this phi.
Fine.
So how, see how will I calculate phi? See this diagram.
Yeah.
So suppose this is your resultant. Z. This is your resultant Z, and if you will join this like this, okay. So this length will be the resistance, okay, and
Yes.
this length will be XL minus XC, okay. So what I have told you, this angle will be phi. So this is XL minus XC, so this also will be XL minus XC, because this is a
Mm.
parallelogram. This is the
Yeah.
parallelogram. This is also
Yes.
XL minus XC. So now see this triangle. See this triangle. So in this triangle, if you will calculate 10 phi, 10 phi if you want to calculate, 10 phi. So 10 phi is given by perpendicular divided by base. So this is the perpendicular of the triangle,
Yeah.
and this is the base of the triangle. So this will
Okay.
become XL minus XC divided by R.
Uh,
XL minus XC divided by R.
yeah.
Okay, so you can write the equation of voltage also. Equation of the voltage will be V is equal to V naught sine omega t plus phi. I am just supposing any random phase difference phi between the current and the voltage. This phase difference sometimes will be 0. This phase difference sometimes can be 90. Sometimes can be other different phase difference. Will it be? Okay. So what is phi? Phi is the phase difference between current and the voltage. Phase difference. Phase difference between the current and the voltage.
Voltage.
So this is the case of LCR series circuit when your when your inductive reactance XL is greater than XC, or you can say peak voltage across the inductor is greater than the peak voltage across the capacitor.
Yeah. Yes.
This is the case. This is the case number first. Now case number second. Case number second. Case number second. If I say that voltage across peak voltage across the capacitor is greater than the peak voltage across the inductor, so we can say that XC is greater than XL. XC is greater than XL. And what is the phase diagram of LCR circuit? This is the phase diagram.
Yeah.
This is the phase diagram. Now, in this case, this thing is greater than this. So this diagram will be
Yes.
modified. This diagram will be modified like this. Sorry. Actually, this time, this diagram will be like this. So here we will have V naught C, V naught L. Here we will have V naught L. So you can see that here this is like one vector in this direction, one vector in this direction, having
Yeah.
the angle pi by 2. So resultant of these vectors will be this. This will be the resultant.
Okay.
This will be the resultant voltage, that is V naught. Okay, and this is angle phi. This is angle phi. Same is the case for this diagram. This diagram will be changed. So here this time XC is greater.
Yeah.
So it will become XC minus XL. Okay. So you can just write it like this. Here will be the resulting resistance, or here will be the resultant, and that resultant will be the impedance of the circuit, making an angle phi. Making an angle phi. From here, if you will calculate tan phi, then you will get XC minus XL divided by R. XC minus XL divided by R you will get. Okay. With the help of the property of triangle, you can calculate this. And from here, if you will calculate the resultant voltage V naught, you will get I naught into under root of R square plus, here you will get XC minus XL square.
Yeah.
XC minus XL square you will get. So this will be the Z impedance of this circuit will be R square plus XC minus XL square. This will be the impedance of the circuit. I naught is the peak value of the current. V naught is the peak value of the voltage. I naught is the peak value of the current. V naught is the peak value of the voltage. Okay.
Yeah. Okay.
So remember this formula if you want to calculate the impedance. So remember this formula only. If you want to calculate the impedance, then this formula is also always valid. Z is equal to R square plus XL minus XC square. Remember this. Why? Because XL minus XC square is equal to XC minus XL square. Because here is square, so there will be no change. You can write either XL minus XC or XC minus XL. Both will be same. Result will be
Okay,
same.
sir.
So you
Okay.
can either, I will suggest you to learn this formula XL minus XC square.
All right.
Or you can learn also XC minus XL, no problem, but at least you should learn at least one formula. Okay.
Okay. Sir.
Okay, now here. Hmm, 10 pi we have calculated, and this is the impedance of the circuit. But phasor diagram, you should know how to draw the phasor diagram. Okay.
Okay.
Now take the screenshots. I am just zooming it out.
Done. 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 Done.
Done.
Yes.
Okay.
Done.
Just wait a minute. I want to write something else also.
Okay.
One simple point I want to write here. Only simple point. Okay. So see this diagram.
Yes.
So I told you the current is in the direction of the, or in same phase with the resistance, or V naught R and I are in same phase. So now equation of the current we have I is equal to I naught sine omega t. So equation of the voltage will be this time. See, this is I,
Yes.
this is I, and this is the voltage. So voltage is lagging the current by phi. Voltage is lagging the current by phi. So this will be V is equal to V naught sine omega t minus phi. So this is the case when your XL, when your XC is greater than XL. And
Okay.
see here, this is your V naught na here. Here is your V naught. So this will be the direction of the I, and here is this phi. Here is this phi. So here the voltage is leading the current by phi. Voltage is leading the current by phi. So you can write the equation of the current. I is equal to I naught sine omega t, and for the equation of the voltage you can write V is equal to V naught sine omega t plus phi. So here I think I have written this. I have written, okay, already I have
Okay.
written. So I want to explain you how I have written. So taken the screenshot of this.
Yes.
Okay, so this will be the impedance.
Oh,
This
no.
will be the
Sir,
impedance.
wait. Can you go to the last slide, sir? I
Mm,
didn't take the pictures.
this one.
Yes, sir. The last one.
Mm, this one.
Yeah. Yeah. Yes. Okay. Done.
Okay. Last case. Case number third. Case number third, when V naught L is equal to V naught C, or you can say XL is equal to XC. Basically, this case we will discuss in the detail. Basically, this is the condition of resonance. Resonance will be a separate topic. So there we
Okay.
will study this thing in detail. So phasor diagram when you will draw. So phasor diagram will be like this. Voltage across the resistance and the current is this, and peak value of the voltage you will get V naught R, and this circuit will behave as a pure resistive circuit. Pure resistive circuit. And there will be only resistance in the circuit, so impedance of the circuit is equal to R. You can just derive Z equal to R from this formula. What is the total impedance of the circuit? R square plus XL minus XC
XC
square.
square. Yes.
But in this case, XL is equal to XC. So
Yeah.
Z will become R square plus XL minus, in terms of XC, you can put XL. So this is XL and XL is 0. So Z equal to under root of R square means Z is equal to R. So impedance of the
Okay.
circuit will be only the resistance. So that is why I am saying this circuit will behave as a pure resistive circuit. That is why I am saying. And if you want to write the equation of the current and equation of the voltage, then equation of the current is this: I is equal to I naught sine omega t. Equation of the voltage will be also this: V is equal to V naught sine omega t. If you want to prove, you should know what is phi. Tan phi. Tan phi is equal to XL minus XC divided by R. Here XL is equal to XC. So now you can find from here tan phi. So XL and XC both are equal, so this will become 0 by R. This is equal to 0. So tan phi is equal to 0 means phi is equal to 0. So you will put here phi is equal to 0. You will get the equation of the voltage. V is equal to V naught sine omega t. So equation of the current and the equation of voltage. In case when XL is equal to XC. This is the case when XL is equal to XC. There is one question. First copy this, then we will solve that. All your concepts will be clear. All your concepts will be clear from that question.
Okay. Done. Done.
Okay. This is the question. And in this question, series LCR circuit is given and the equation of the current is given. Equation of the current is given.
Yeah.
Capacitance 500 microfarad. Resistance is 3 ohm. Inductance of 0.16 Henry is given. So this is the condition given, and they are asking calculate number one XL. 10 parts given. So one by one we will solve the parts.
Okay.
Answer first. First they are asking the XL. What is XL? XL is equal to omega L.
Yeah.
So for that we should know what is omega. So first we will calculate omega. First we
Okay.
will calculate omega. So now for calculating omega, equation of the current is given in the question. I is equal to I think 10 sine omega t. I is equal to 10 sine omega t is given. See, the equation of the current is given in the question. I is equal to 10 sine, not omega t, 10 sine 100 t. What is the standard equation of the current we have derived? We know I is equal to I naught sine omega t. I is equal to I naught sine omega t.
Hmm. Yes.
This is your equation number first. Suppose this is equation number of second. Now compare equation 1 and second. Compare equation 1 and second. Your I naught will be 10 ampere.
Yes.
I naught means peak value of the current will be 10 ampere. What is omega? Can you tell me what will be the
100
value
T.
of omega? No, not 100 T.
Okay, 100.
Omega is equal to only 100.
Yeah, yeah.
Okay.
Okay.
Omega is equal to 100
Yes.
radian per second. Radian per second. Now we can find XL. XL is equal to omega L. XL is equal to omega L. So omega is given as 100. What is the value of L? 0.16. Okay.
Okay.
0.16 in Henry. 0.16. So XL will be 16 ohm.
Yes.
XL will be 16 ohm. Unit of XL is ohm. Okay. Second part. First part is finished. Second part.
Yes.
XC. There we have to find XC. Second part.
Yes.
So XC is given by 1 upon omega C. So 1 upon omega is 100.
Yes.
Capacitance is given 500 microfarad, I think. 500. 500 microfarad. So 500, this is 100 and this is 500 microfarad. 500 microfarad into 10 to the power minus 6. 1 microfarad is equal to 10 to the power minus 6 farad. Micro means 10 to the power minus 6.
Okay.
So when you will solve this, you will get answer this. Now we are solving. This is 10 to the power 6 and we can write this as 5 into 10 to the power 4 and we can write here 10 into 10 to the power 5 and this is 5 into 10 to the power 4.
Okay.
So this when you will cancel, this will become 2
2.
and this will become 10. So basically it will become 20 ohm. What is your XL? 16 ohm. What is your
Yeah.
XC? 20 ohm. So from
Yes.
here it is clear that XC will be greater than XL. This will be used. This result will be used.
Okay.
After that they are saying Z, impedance of the circuit. Answer third.
So what if XL is greater?
X, here you can see, this is the value of XC is 20
Yeah.
and value of XL is 16.
Yes.
So 20 is greater than 16.
Yeah.
That is why I have written XC is greater than XL.
Okay.
Now they are asking Z. What is the formula of Z? That is impedance. Z is equal to under root of R square
That's
plus
good.
XL minus XC square.
Yeah.
Okay. What is the resistance given? 3 ohm. So means 3 square. 3 square. What is XL minus XC? XL is 16. XC is 20 square. So this Z will become 3 square plus 4 square. So your Z is 5 ohm. Z will be 5 ohm. Okay, this is 3 square and 4 square. 4 is 3 square plus 4 square will be 25. 25 root is 5 ohm.
Yeah.
Fourth part. They are asking 5. They are asking 5. 5 means the phase difference between the current and the voltage. What is the meaning of the 5? Phase difference between the current and the voltage.
Sir,
Yeah.
the screen sharing is lagging, sir.
Screen share. Check your internet.
Okay.
I am checking mine.
Because it's lagging in between, sir. That's why.
No problem. There can be any other issue. My internet is okay, but if there is any issue, then we will find out. No problem. Is your internet speed is okay?
Yes, sir.
Screen is just lagging. My voice also
Yeah,
is lagging.
yeah,
So,
yes, sir.
but my internet is very nice this time.
I think it's
Uh,
from my side only, sir. It's lagging.
Maybe it can be.
Yeah.
Okay, so got it now? How to calculate Z R square plus XL minus XC
Yes.
square.
Yes, sir.
Now fourth part. Fourth part, they are asking phi. Phi is the phase difference between the current and the voltage. They are asking phi. What is phi? Phi is phase difference. Phase difference between current and voltage. We know tan phi in case when your XC is greater than XL. Tan phi in case XC is greater than XL. See here. Tan phi. This is the case when XC is greater than XL. And what is the value of the tan phi here? See, this is the tan phi. Tan phi is XC minus XL by R.
Yeah.
So we will use this equation. So tan phi is XC minus XL by R. What is the value of XC? 20. What is the value of XL?
18.
16. What is the
Yeah,
value of?
16.
Actually, this is XC minus XL
So
by
I think
R.
it's 16, sir.
Yeah, it is 16. This is R. Just wait a minute. I want to see one thing. R is R is 3. So we will put here 3. So this will become 4 by 3. So your tan phi is equal to 4 by 3. So from this you can write phi is equal to tan of inverse 4 by, this is your phi. Now fifth part, they are asking equation of voltage. They are asking equation of voltage with time. Equation of voltage with time. Equation of voltage with time. Answer fifth. For that, I want to show you this with the help of the phasor diagram. So how will be the phasor diagram? Here in this case, we know that XC is greater than XL.
Yeah.
So XC is greater than XL. So
Yes.
here will be the voltage, peak voltage of resistance, and XC is greater than XL means if current is in this direction, current is like this, then here will be your peak voltage across the capacitor minus peak voltage across the inductor.
Hmm.
And here somewhere here will be the resultant of the voltages, that is V naught. That is V naught. So this is your V naught and this will be phi. This will be phi. So equation of the current is I is equal to I naught sine omega t. Sine omega t. So
Yes.
what is I is equal to, what is I naught? I naught if you want to calculate, so you will write I naught is equal to V naught by R. Okay.
Yeah.
This is the equation. So I naught is 10. I naught is 10
Yes.
na?
Yeah.
I
Yes.
naught is 10 and omega is 100. So these values we will use. So I naught is 10. So equation of the current, if I want to write, equation of the current is given. So there is no requirement. equation of the voltage I want to write. Equation of the voltage. So equation of the voltage in this case will be V is equal to V naught sine omega t minus phi. Okay. This is
Okay.
the current and this is the phase difference phi. So you will write omega t minus phi. You can see here also. You can see here also. When your XC is greater than XL, na? So see the
Yes.
equation of the voltage. V is equal to V naught sine omega t minus phi. Okay. So now we will calculate V naught first. V naught is equal to I naught into Z. So V naught, what is I naught? I naught is 10.
Yeah.
I naught is 10 and Z is 5. This will become 50 volts and omega is this. So from this we can calculate the equation of the voltage. Okay. So now equation of the voltage V is equal to, what is V naught? 50.
50.
This
Yeah.
is sine. Omega is 100.
Yeah.
100 t. What is phi? Phi is this 10 inverse 4 by 3. So instead of pi we will put minus 10 inverse 4 by 3. So basically this will be your equation of voltage. This will be the equation of the voltage in this circuit. V suffix t means equation of voltage with time. So here is time, na?
Okay.
This is time.
Yeah.
So you can write this like this also.
Okay, sir.
V suffix t is equal to 50 sine 100 t minus 10 inverse 4 by 3. No problem.
Sir,
Yeah.
can I rejoin the meeting, sir?
Okay. No problem. Now it's okay.
Yes, sir. No, it's okay.
Sometimes, na, there are so many, you can say, apps or functions working at the same time in the laptop. So the
Yes, sir.
processing of the laptop sometimes becomes slow. So
Yeah.
this can also be the reason. Uh, okay. So there can be
Okay.
the problem in my system also because okay. So
Hmm.
so this is the voltage equation now. Okay. Next part. Sixth part. VRT means voltage across the resistance. Voltage across the resistance.
Okay.
This is the fifth part. Now we will solve sixth part.
Okay.
So voltage across the resistance with time is given by the peak voltage across the resistance sine omega t. Simple. Because
Hmm.
what is the equation of the current? Equation of the current is I is equal
Is-
to I naught sine omega t. Na?
Yes.
And in this question, the equation of the current is given as I is equal to 10 sine 100 t.
Yes.
Okay, so basically we have omega. Okay, we do not
Okay,
have
sir.
this peak voltage across the resistance. Peak voltage across the resistance is given by the current, peak current into resistance. Simple. Because current will be same throughout the circuit. So peak value of the current is 10, resistance is 3. So this will become 30 volt. Now voltage across the resistance is equal to, instead of this V naught R, I will put 30. So this will
Okay.
become 30 sine omega is 100.
100T. Yeah.
Now seventh.
So this was for resistance, right?
Yeah, this is the resistance across the this is the voltage across the resistance with time.
Okay. Okay.
In the beginning, I have written all the equations. Yes, see here. You can see here. The
Yeah.
beginning, I have written all the equations. See the voltage across the resistance. This and this. So that there should be no confusion. One or two time when you will revise, no problem. You can do it.
Okay.
Uh, they are asking part number 7, voltage across the inductor. Voltage across the inductor. They are asking this. Voltage across the inductor. So voltage across the inductor, what is the equation? V is equal to peak voltage across the inductor sine of omega t plus pi by 2 or minus pi by 2?
It's leading, so plus 5 by 2. Right?
Yeah, plus 90 degree.
Okay. Yeah. Hmm.
Omega t plus 90 degree.
Okay.
Just a minute. See this diagram is phi and this is current I. So this is your phi. So basically phi is tan inverse pi by 2. We want to write the equation of the voltage. So fine. Sine omega t plus pi by 2 plus 90 degree. Plus 90 degree. Okay, so we can find this V naught L is
Yeah.
equal to, voltage is equal to peak current into XL. What is XL? XL is 16 and I naught is 10. This is 10. This is 16.
Yeah.
You can check. Okay.
Mm,
I naught is 10. This is 16. So this will become 160 volt.
yeah.
So now we can find this VL T is equal to 160 sine omega is 100. This is T plus 90 degree.
Yeah.
Okay. Now in the 8th part they are asking voltage across the capacitor. This is given by V is equal to peak voltage across the capacitor sine omega t minus pi by 2. Omega t minus pi by 2 or minus 90 degree.
Yeah. Okay.
So we do not have V naught C. So we can find this. This will be I naught into XC. What is I naught?
XC.
10,
X.
XC is 20. This
Yeah.
will become 200 volt.
Yeah.
Now we can find V suffix T, that is equal to 200 sine omega is 100. This is T minus
100 minus 90.
90 degree.
Yeah.
Anything else? Power factor. So power factor will be the uh, next topic, or average power. When we will calculate the average power, then we will discuss the power factor again. Okay, but just I am telling what is the power factor. Okay, what is the
Okay.
power factor? Just I am telling. So this is the 8th part. In 9th part, actually here I have written in Roman numbers and these
Yeah.
are in simple number. So I am just changing it. This is 1.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, and this is 9. In 9 they are asking power factor. So basically we will discuss power factor.
Hmm.
So power factor is known as cos phi. Phi is the phase difference between the current and the voltage. Cos phi. Okay. Now what is the value of phi we have? Tan inverse
Yeah.
3 by 4
Yeah.
we have now.
Yes.
Tan inverse 3 by 4. So we can write it as tan phi is equal to 3 by 4. So we can make a triangle. We will use a maths here. We can make a triangle.
Okay, sir.
There is a triangle having 4. Basically, what is tan phi we have? 4 by 3 or 3 by 4? 4 by
3 by
3
4.
are we? No, not a 3 by 4.
Okay.
This is 4 by. So the triangle will change.
Okay.
So this is basically 4 by, not 4 by 3. This is 4 by 3. So we can write tan phi. This is the inverse of the 10. This side will be, this will come tan phi. We can write this as 4 by 3. So basically this triangle will be 4, 3 and 5. And this angle, this is the special type of triangle. Okay. So
Okay.
remember this triangle. This is the triangle. If sides are like this angle is 53 degree. If sides are like
Yeah.
this is a right angle triangle. If
Yes.
sides are like this, 3, 4, 5, this angle is 37 degree. So these two triangles basically used. So tan phi is 4 by 3. So basically this triangle we will use. Okay, this triangle we will use. Because see here tan phi is equal to 4 by 3. Okay,
Yeah.
so so 4 by 3. If I want to find the cos phi, so cos phi is equal to base divided by hypotenuse. So base is 3,
Yeah.
hypotenuse is 5. This is become
Yes.
3 by 5.
3 by
So
5.
basically power factor is 3 by 5.
Yeah.
But here na Ziyad, uh,
Yes.
basically this triangle you have to remember. Our
Okay, sir.
answer is our answer is tan inverse 4 by 3. That time I have not told you that this tan inverse 4 by 3 is given by 53 degree. Okay, basically tan inverse 4 by 3 is 53 degree. Why 53 degree? From this triangle. Okay,
Okay, sir.
so next question 10, answer number 10. They are saying the average power. So basically the average power, I will drive what is the average power. We will have a topic after that, after this average power. So average power is given by VRMS into IRMS into cos phi. And I have told you what is VRMS, V naught by root 2, and
Yeah.
IRMS is I naught by root 2, and cos phi is 3, cos phi is 3 by 5 cos phi. So this will become I naught into V naught by 2. This will become V naught I naught by 2 into cos phi. Okay, so what is the V naught of the circuit? What is the V naught of the circuit in this question? See here. This is the V naught. V
Yeah.
naught is 50.
Yes.
This V naught is equal to 50 volt. So here we will put V naught as 50. I naught is 10. This is 2. This is 3 by 5. So what answer we will get? 150 joule. Watt. This is 5 to the 10. This 10 and 10 will be cancelled out. This is 53 is a 150 joule. Oh no, not joule, yeah. Watt. The unit of power is watt
Yeah.
or joule per second. So this is your average power. This is your average power. So this is very lengthy question, and don't think in examination this question will appear. But the
Okay.
part of some, they can ask you calculate Excel and calculate this two parts and any three parts they can ask. I have told you all the parts so that your concepts will be should be clear. Okay.
Okay.
Okay. So now you can just uh, note down. Take the
Sir,
screenshot. Yeah.
what is the next chapter after this one?
Next chapter will be the electromagnetic wave.
Okay, sir.
Have you completed that electromagnetic wave?
In class, yes, sir.
Basically, electromagnetic wave is not a very lengthy chapter. That chapter is very easy chapter. Okay. So, and after the electromagnetic wave, we will start the optics. Optics, na reflection and reflection, all that.
Yeah, because after this chapter we did optics, sir.
We should do optics. You are saying that.
Yes, sir. Yeah.
Okay, no problem. I can start that optics. For me, it is no problem. If you want that I should start the optics, then it is okay. I can start. No problem. But if so, okay. Means you do electromagnetic waves is okay for you. Means you have completed in a proper manner. मेरा कहने का मतलब ये है कि इलेक्ट्रोमैग्नेटिक वेव आपने अच्छे से कर रखा है, आपको तो यहाँ पढ़ने की जरूरत नहीं है.
Yeah.
Okay.
Done, sir.
Okay.
Done, sir.
Done. Okay.
Yeah.
Done.
Yes.
Okay. So
Done, sir.
okay, Ziyad. So after this chapter, I will
Yes.
start the chapter that you want, that is optics. Okay.
Okay. Sir.
Hmm.
Yeah. Done, sir. Can you scroll down, sir?
Hmm. Do you want to ask anything else?
Yes, sir. Just a second. Sir,
Hmm.
I've sent you this one question, sir, on WhatsApp, right? Sir, can you explain this one?
I have just explained this question to you.
Okay, it's the same one, sir?
Hmm. Actually, this thing, na, this impedance triangle, as I have
Yeah.
told you, yeah, this is the case. And the second part you have sent me, that is the average part that we will discuss later.
Okay, sir.
That is the derivation of average part. Okay, so impedance triangle is basically like this. This is the impedance triangle. This is this.
Okay.
I am saying now that time this
Yeah.
see this triangle. So
Yeah.
basically, this is the impedance triangle.
Oh, okay, sir. Okay.
So basically, this is the whole method to solve from where you are getting that impedance triangle. If
Yeah,
suppose I
because
am,
it's
if
confusing in class, so
yeah,
that's why.
if I will say that this is a triangle
Yeah.
and here is Z and this angle is phi and here is XL minus XC. So there will be some problem in understanding.
Yes,
Here
sir.
I have told you the whole process. This is the triangle
Yeah.
basically. Hmm. So, okay, and this the next derivation is basically I have told you that formula, this formula of RMS now.
Yeah.
This is the formula. We will have that whole topic for this C VRMS IRMS cos phi V naught I naught cos phi by 2. You can see here. So I will discuss, no problem. It will take some time. Okay. So
Okay, sir.
very easy. If you just, I am giving the hint. Okay. If you want to do, I have another class at after you na. So
Yeah.
basically in the next class I will discuss. So basically I want to give you the idea how to solve it. Basically average power you want to calculate. So you should know what is power. Basically power is given by voltage into current. So in a AC circuit, voltage changes with time and current also changes with time. This thing you should
Yeah.
know. So
Okay,
you
sir.
can write in the circuit the power at any time is equal to the voltage at any time and current at any time. Okay, this is, suppose this is small I. So now
Okay.
what you will do now, you will write the equation of the voltage and the equation of the current. You will write the equation. Suppose the equation of the voltage is V is equal to V naught sine omega t, and equation of the current I is equal to I naught sine omega t plus phi. What is phi? Phi is the phase difference between the current and the voltage. This is
Voltage. Yeah.
PT. This is the function of power in time. Now you want to find the average power. So there are two methods. First method is very lengthy method. You have to do the integration like this. Then you will
Okay.
get the result V naught I naught by 2 into cos phi. This result you will get, you can see in your notes. And
Yeah.
there is one another method that I will tell you tomorrow. I have told you na, that the average value of sine omega t for full cycle is equal to 0.
Yeah. Yeah.
Average
Yes, sir.
value of sine square omega t for full cycle is equal to half. So this method I will prefer. I will not prefer this method because this method will be very lengthy. Okay.
Okay, sir.
Okay. And in the next class we will discuss, but at the same time I am saying, no matter you can learn anything, but please revise your notes. Okay.
Okay, sir.
uh, Again and again I am saying, because suppose here if someone is asking what is the phase difference between the voltage and the current in case of the inductive circuit, then you should know it is 90 degree. And in case of inductive circuit, if the question is asked from you that in an inductive circuit whether the current is leading or the voltage is leading, so this, at least this basic things you should know. Okay, so in the next class we will discuss the power. Okay, and
Okay,
maybe
sir.
I will try to finish the resonance. We will discuss the resonance,
Hmm.
and
Okay, sir.
after that we will discuss a last topic, the transformer.
Okay.
Okay, and after
Okay.
that we will start optics if you want.
Okay,
Okay,
sir.
you want
Okay.
now, I should start optics.
Sir, before you, which one you were doing? Before updates, you said you were gonna start another chapter, right?
After this chapter, after this there is a chapter known as electromagnetic waves, and after the electromagnetic wave, first part of the 12th, first book of the 12th is completed. Next part is, means after the
Okay.
electromagnetic wave there is the optics, that is refraction, reflection and diffraction and all that thing,
Then
interference.
okay, sir. You can start electromagnetic waves tomorrow.
Yeah.
Oh,
Electromagnetic wave takes at least I will say 2 lectures and 2.5 lectures
okay.
to be
Okay, sir.
completed.
Oh, no problem.